Hello friends and my dear students, I welcome you all to my channel. This is part 12 video on the chapter of probability. From this video, in the next 2-3 videos, I will discuss about possible outcomes and favorable cases of an event in a given random experiment. It is very important to understand in a random experiment what are the possible outcomes, or you can say possible outcomes are also termed as elementary events, and given an event, what are the favorable cases that is satisfied by the conditions of the given event. I will explain this with a few examples. In this example 1 and 2, I will the random experiments that I will discuss is tossing a single coin and tossing two coins simultaneously. So these the next couple of videos will be very important for you to understand the possible outcomes of a random experiment and the favorable cases to find the probability of an event. So please watch this very carefully. After these videos, I will try to solve few problems. So this video is part of the playlist CBSE Maths for class 9, following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 12 video, where I will be discussing the possible outcomes and favorable cases for some events in two random experiments, that is tossing a single coin and tossing two coins simultaneously. Okay, so so the first example is, the experiment is we are tossing an unbiased coin, a single unbiased coin. Now what is meant by an unbiased coin? You might have heard biased and unbiased coin. A coin is said to be a coin when you toss a coin, it is said to be biased if the number of times the head appears and the number of times the tail appears, they are not their frequency is not same. Their frequency should be it may not be exactly same, but very close to each other. Like there should be 50% chance that a head will show up and 50% chance a tail will show up. Meaning, if you toss a biased coin 10 times, approximately 5 times it should show up head and 5 times it should show up tail. In that case, the coin is said to be unbiased. And whenever higher classes, and in this class also, mostly we will deal with unbiased coins and unbiased dice. Now what is a biased coin? What is a biased coin? It is the opposite. That is, there is no guarantee that if you toss biased coins 10 times, there will be approximately the number of occurrence of heads and the number of occurrence of tails, they could be very much off. That is, it may be 2 times head shows up and 8 times tail shows up. So those type of coins are called biased coins. Anyway, so example 1, the experiment is we are tossing an unbiased coin. The first thing we need to understand is what are the possible outcomes. I am denoting the possible outcomes with PO, and the possible outcomes, I will represent the possible outcomes of a random experiment with a set. As you can see, as of now I have written a question mark. I will fill up what are all the possible outcomes of the random experiment of tossing a unbiased coin. Obviously there are two possible outcomes, either it will be a head or it will be a tail. So those possible outcomes, the outcome that a head shows up, I am denoting it with H, and the outcome that a tail will show up, I am denoting it with tail. So there are two possible outcomes, H comma head. So I can say that for this random experiment, so there are two possible outcomes. As you can see, this set it has two elements, one head and one tail. Okay, so these are the possible outcomes. For any random experiment, you must be very clear about what are the possible outcomes. Okay, now I have defined some events on the right hand side. E1, let's say E1 be the event head shows up, E2 be the event tail shows up. Since we are dealing with only one coin, head shows up, tail shows up. E3 zero heads, zero head shows up. E4 is zero tails. E5 one head and E6 one tail. Now some of these events from E1 to E6, they could be same, they could mean the same thing. Okay, now let's see now what are the favorable cases of the event E1. Event E1, it is an event, and for a random experiment, when an event is defined, we must have some favorable cases, and those favorable cases are primarily the elementary events from the possible outcomes. Okay, so let's see. So the favorable cases for the event E1, I am denoting it as FC E1. FC stands for favorable cases. FC E1 means what are the favorable cases out of all the possible outcomes that satisfies the condition of the event E1. So I will now fill up this set. So head shows up. Definitely the only element of the only of all the possible outcomes, the outcome that satisfies the event E1 will be head. Similarly, what will be the favorable cases? So for the event E1, you know, we denote it in the formula of empirical formula of a probability. We know the probability of an event E is equal to small m, which is the number of cases favorable or number of outcomes favorable to the event E divided by total number of possible outcomes, small n. In this random experiment, small n is 2. It will always be 2. So for the event E1, what is small m? For the event E1, small m will obviously be 1, because we can see in the set we are having only one outcome H. So m is 1. Let's see what are the favorable cases for the event E2. Event E2 says tail shows up. So quite obviously the only outcome from the possible outcomes that satisfies the condition of the event E2 will be tail. So here also the small m for the event E2 will be equal to 1. Let's see the event E3. Event E3 says 0 heads. Now 0 heads indirectly means one tail. So that is 0 heads means tail shows up. So actually event E3 is equal to event E2. They are the same identical events. So definitely the favorable cases of event E3 will also be this tail, and small m will be 1. Let's see event E4, 0 tails. 0 tails means a head shows up. So I can say E4 is actually identical to the event E1. So the favorable cases for the event E4 will be H. So here also m is equals to 1. Okay, let's see event E5. It says one head. One head also means head shows up. So event E5 is identical to event E1. One head. Okay. So E5 will also be what are the favorable cases? That is, what are the possible outcomes that satisfies the event E5. It will be H. Here also m is 1, and similarly event E6 is one tail, which means E6 is identical to the event E2. So the favorable cases for the event E6 will be tail, and we have m equals to 1. Now if it was, let's say, another event E7, two heads, quite obviously the favorable cases for the E7, there is no outcome in the set of possible outcomes which satisfies the event two heads, because two heads can never show up as we are tossing only one coin. So this the favorable cases of the event E7 will be empty. Empty set means there is no possible outcome which is satisfying the condition of the event E7. So m is 0. So now once you know small m, value of small m for all these events, then you can easily find the probability of all these events. Like probability of E1 will be equal to m, its m value divided by n2. Similarly, probability of E6 will be also equal to 1 by 2, and probability of E7 will be 0 by 2, which is equal to 0. Okay, let's see the next example, which is we are tossing two unbiased coins simultaneously. So when two unbiased coins are tossed simultaneously, what are the possible outcomes? PO. What will be the collection of possible outcomes? Okay, so okay. So the first coin can show up either head or tail, and the second coin can also show up either head or tail. So I hope you will have no confusion if I say that the possible outcomes of two unbiased coins tossed simultaneously will be something like this. It can be two heads, both the first coin and second coins are head. Both the coins can show up tail. The first coin shows up head, the second coin shows up tail, and the first coin shows up tail, and the second coin shows up head. There are only 4 possible outcomes of this random experiment, which is tossing two unbiased coins simultaneously. So in this random experiment, small n, total number of outcomes is 4. Now I have defined some events on the right hand side. E1, one head means one head shows up, two heads like this, two heads, two tails, zero heads. Let's try to define all the favorable cases for these 9 events. Event E1 means one head. You see all the possible outcomes that satisfies the event E1, that is one head. Head is not satisfying one head because it has two tails. Clearly we can say the possible outcomes which is satisfying the event E1 are head tail and tail head. These are the two possible outcomes that is satisfying the condition of the event E1, which is one head. So for this, the event E1, for the event E1, small m, that is the number of favorable cases to event E1 is 2. Let's see event E2. Event E2 says two heads. So obviously among all the possible outcomes, which outcomes is satisfying the condition of the event E2? It is only head. So for this event E2, small m is equal to 1. Let's see E3. E3 says two tails. Obviously the only outcome that satisfies the event E3 will be tail. and small m for this event E3 will be 1. Let's see E4, 0 tails. E4 says 0 tails. Now I have to see in all the possible outcomes which outcomes is satisfying the condition that there is no tail. Obviously it will be head. Only the outcome head has no tails. So m is equals to 1. So you can say E4, event E4 is identical to event E2. Okay, let's see event E5. Sorry, event E5 says 0 heads. 0 heads means obviously 2 tails, so it will be tail. Small m again is equal to 1. So I can say E5, the event E5 is identical to E3. Let's see event E6. Event E6 says at least 1 head. So since there are two coins tossed, at least 1 head means I can have 1 head or 2 heads. So what are the possible outcomes for 1 head? So actually it will be so E6, the event E6 is identical to saying E1, or E1 means 1 head, or E2. The event E6 is saying at least 1 head. So it means that I can have 1 head or I can have 2 heads, since there are 2 coins. So 1 head means the event E1 and 2 heads means the event E2. So the occurrence of event E6 is equivalent to the occurrence of event E1 or the occurrence of event E2. So what will be the collection of the favorable outcomes of E6? It will be all the favorable outcomes of E1 and all the favorable outcomes of E2. So what are the favorable outcomes of E1? It is head, tail and tail and it is head and tail and edge. And what are the favorable cases for E2? It is head. So we see for the event E6 there are 3 possible outcomes, which is there are 3 possible outcomes, which is satisfying the condition of E6, and clearly we see that m is equal to 3. Okay, let's see event E7. It says at most 3 heads. At most 3 head means it can have 3 heads. It cannot have 3 heads because we are dealing with 2 coins. So 3 heads is not possibility. Definitely we can have 2 heads, we can have 1 heads, and we can have 0 heads. So E7, the event E7 is equivalent to saying I can have 2 heads, which is E2, or I can have 1 head, which is E1, or I can have 0 heads, which means E5. So what are the possible outcomes then for event E7? It will be the possible outcomes of E2 and possible outcomes of E1 and possible outcomes of E5. So what are the possible outcomes of E2? We have head. What are the possible outcomes of E1? We have head, tail, head. And what are the possible outcomes of E5? It is tail. So these 4 outcomes, that is head, tail, head, tail, these 4 possible outcomes is satisfying are the favorable cases of the event E7. So for this event E7, m is equal to 4. Okay, let's see event E8. E8 says all heads. Now all heads means 2 heads. So event E8 is basically equal to E2. They are the same event. So the favorable cases to event E8 will be the favorable cases to event E2, which is head. So here for the event E8, small m is equal to 1. Let's see event E9. Event E9 says all tails. All tails means definitely there is one outcome, tail. Small m equals to 1. And obviously we will have event E9 is equivalent to event E5. All tails, or even E3. So E9, E5 and E3, they all are the same events, equivalent, identical events. Okay, so now if we are asked what will be the probability of event E6, the probability of the event E6 will be what are the number of favorable cases to event E6? M is 3. So 3 by the total number of possible outcomes is 4. N is 4. So 4. Similarly, the probability of E7, the probability of event E7 will be what is the number of favorable cases to event E7? We are having 4 possible outcomes. M is 4. So 4 by n is 4. It is 1. You can see the event 7 is a certain event. Even event 7, the way it has been defined, it is a certain event because it says that at most 3 heads. Definitely, if you toss 2 unbiased coins, the number of heads will be obviously at most 3, because it will be at most 3 means it can be 0 head, it can be 1 head, or it can be 2 heads. Okay. Yeah, I think I have covered up all the. I mean, there can be more events defined, but I have defined some of the most standard events that are being asked about their probability in the random experiment of tossing 2 unbiased coins. So in this video, I just discussed about the 2 random experiments, 1 single coin tossed and 2 unbiased coins tossed simultaneously, and what are the possible outcomes, and I have defined some events and have discussed what are the favorable cases of all these events and how to find their probability. So this concept will be useful when in solving problems of probability where you will not be given the frequency of some outcome. So these are some standard experiments whose based on the possible outcomes you have to find the probability, and you must know very clearly what are the possible outcomes. Like tossing a single coin, tossing 2 unbiased coins simultaneously, it can be tossing 3 unbiased coins simultaneously, it can be throwing 2 dice simultaneously, it can be randomly selecting a number from a set of numbers. So there are there are many variations of problems that are solved based on the possible outcomes of a random experiment, and out of those possible outcomes, which outcomes are favorable to a given event. So in the subsequent videos, I will discuss more examples, so please stay tuned. If you find this video beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I am ending the video here. Thanks for watching, and until the next video, take care and bye.